So let's see the program in Python. Okay, let's zoom it. First, you have to import few modules. So these are your NumPy, Matplotlib, and sklearn module. Then next is you have to load data from your input file. So we are using loadtxt function of NumPy package, and we have taken the file data quality.txt. Now what is that file containing? Let's see it. This is your data quality.txt file, and this file is containing two numbers separated by comma. Again, two numbers separated by comma. So you can say that this is two-dimensional data you have, and you have taken this data set mixed. We have used your delimiter equals to comma for separating our data, that is two numbers. Next, we have to plot our input data. So we are using scatter function for that, and x is denoting your data set. We have used your color black, and marker is O. Next, we have calculated here minimum and maximum values for x and y, so that we can plot, we can give your limit values, x limit values and y limit values. We can set these values to our plot, and we have given the title input data to our plot, and then we have set labels to our x-axis and y-axis using these functions. Next, we have to initialize variables. So we have initialized your scores, that is denoting your array of Silhouette scores, and values. Values is denoting, that is np.arange 2 to 10. So it is denoting 2 to 9. That is array will be like this, 2, 3, 4. So this is your values array. We have taken this array. Next, why we have taken this array? Because this array is denoting the number of iterations we have to take. Number of iterations are depend on number of clusters, you can say. So these are different you can say different number of clusters for that. Next, we are using a loop. So for number of clusters and values, so values, you know, that is 2 to 9 array, and we are using this variable number of clusters. So we have trained the k-means clustering model here. Now you know that what is k-means. This is your algorithm for clustering. So we have used here initialization parameter as k-means ++. Number of clusters will be equal to n clusters, and n in it is your parameter, refers to the number of times the algorithm should run before deciding upon the optimal number of, that is your best outcome. You can say the proper location of your centroid, that is your n in it, that is number of iterations. Okay. Next, we are using the fit function. Then we are calculating Silhouette score for that model. So that model will give you some clusters, because this is your clustering model. So we are calculating Silhouette score on that using labels. So k-means dot labels, and metric will be your Euclidean, and you know that Silhouette score can work on any metric that you have, and your sample size will be your length of your data x. Next is your number of clusters will be your this, and Silhouette score will be your this score, and then you append your score to the scores array. So this iteration will go on, and scores will be calculated and append to the scores array. So that was your important task here, that you have to run that loop and calculate scores for different number of clusters which we have taken in our values array as an example. Next, we are plotting our Silhouette scores. So for that we are using the bar function, because we have to plot bar graph. So we have taken the width 0.7, and scores will denote your y-axis and values will denote your x-axis. So values will denote your number of clusters, and scores will be your Silhouette scores, and color will be your black, and alignment will be your center. So title will be Silhouette score versus number of clusters. And next is you have to extract best score and optimal number of clusters. So best score will be your, you can say the optimal number of clusters will be your np.argument max scores plus value 0. Now what is value 0? That is your 4 here. And what is this? This is your 2 here. No, this is your 2. Value 0 is 2 because your values array was that array. And this is your 2. So value 0 is 2 and your argument max is your 4. So now what is 4? 4 is representing your index at which your score is maximum. So in this way you can calculate number of clusters and then we are displaying that plot. So that was your program for calculating Silhouette scores and determining the quality of clustering. Now let's run this program. Now see that this is your plot of input data 1, 2, 3, 4, 5, 6. So there are 6 clusters in your data and this is your bar graph. So that bar graph is containing see x-axis 2, 3, 4, 5, 6, 7, 8, 9. This is your values and these are your scores, Silhouette scores. Now see, this is maximum Silhouette score which is for number of clusters 6. So for number of clusters 6, Silhouette scores will be maximum and this is showing that quality of clustering is maximum and good at that score. So by determining the score we can calculate the optimal number of clusters for our data set. So in this way you can calculate your quality, and by visualizing our data you can easily see that there are total 6 clusters in our data set and that can be determined using that method. So that's it. You can determine the quality by drawing the plot of Silhouette scores. Okay, thank you.